hello, and welcome to the show. It's me, John Park. It is time for JP's product pick of the week. I have a cool product pick for you, so thank you for stopping by to check it out, and also maybe to get yourself a big, humongous discount on this week's product pick. So first thing I want to do, in fact, is send you to the product page. So if you go to this URL or to this QR code right here, however you like to do it, you'll end up on this week's product pick page. And this show is actually embedded right inside of the product page, so you can watch it from right inside of there if you like that virtual shopping mall Barker type of situation experience. And the cool thing is, you don't need a coupon code. All you got to do, if you want this week's product pick, is throw it in your cart, and it's going to be on a big, humongous discount. I'm refreshing my page in the background here to check it out because I believe it's, yes, 50% off on this week's product pick. So if it's something you're interested in, check it out. Oh, hey, thanks, John Milton. John Milton pointed out a typo in my, is that in the YouTube, that I put the wrong date? Let's see if I can I fix that? I don't think I can while it's running. Let's find out. Yeah, sure. I said it was the 4th. I'm not encouraging time travel, so let's correct that. Here we go. Ooh, save. Okay, that should update. Thank you, John. And hey, thanks everyone for stopping by over in the various chats. I see you over there in YouTube. So hello, Jeff Hunt and Paul Curry, Old Aesthetic Quinman16, as well as John Milton. Hello. Thanks for stopping by the YouTube chat. If you're somewhere else and you're wondering, hey, who's he talking to? Where's the chat? You might want to check out our Discord, which is over at adafruit.it/Discord, and you can look for the live broadcast chat channel right there. And that's where some people are hanging out. So hello, C. Grover and Debo Dog and Blitz City DIY. Hey, Liz. Hey, Jeff. Hey, Thin Man. Hello, Jim. Hey, Gavin. Thank you for jumping in here and hanging out today. All right, so this is perhaps the shortest new video from Lady Ada that I have ever experienced. So I'm going to play you a 16-second new video from Lady Ada. She will just introduce it a little bit, but then I'll give you a lot more detail on this week's product pick. So very briefly, take it away, Lady Ada.
Oh, it's our TFT Shield reborn like.
Oh, oops! Technical difficulties. Hold on. You get to hang out here for a second while I add the right video in. All right, it's going to autoplay.
Oh, it's our TFT Shield reborn like Phoenix from the flames. This is one of the oldest boards that did not make it through COVID/part shortages /TFT pricing inflation. It's been a journey. So. The AD5693, we've had requests for more bits on the DACs. People are always emailing you. You know that email you get every day? Where's my 16-bit DAC? Where are the bits on that? More bits. We have a 12-bit DAC. Now we have a 16-bit DAC coming soon, but we got some photos taken. The AD5693.
Yeah, I probably should loop it. It's so short. Okay, let me give you a proper introduction, because if you blink, you'll miss it. Here's Lady Ada introducing this week's product pick, and that'll give you some more details. Here you go.
The AD5693, we've had requests for more bits on the DACs. People are always emailing you. You know that email you get every day? Where's my 16-bit DAC? Where are the bits on that? More bits. We have a 12-bit DAC. Now we have a 16-bit DAC coming soon, but we got some photos taken. The AD5693, we've had requests for.
All right, that's enough looping of that. Yes, so there it is. There is my product pick for this week. It is the AD5693R 16-bit DAC Breakout board. This has STEMMA QT, so it's really easy to connect up over I2C. You can see I've got a little cutie pie plugged in here. And then you can wire any kind of plug or terminal screw or combination of those things out, or use the pins, put little pin headers on there, put it into a breadboard or permaproto, and you can send out analog voltages. So this is digitally controlled, DAC, digital to analog converter. It'll take your digital commands, which you can program inside of, what can you program it in? You can program it in Arduino, you can program it in CircuitPython. You can also run it in Python using Blinka on a Raspberry Pi or similar computer. And this will send out really, really highly accurate voltages. So this is great for any case where you want to send out voltages anywhere from 0 to 3.3 volts if you're using 3-volt logic, or 0 to 5 volts if you're using 5-volt logic. And it has a very stable internal 2.5-volt regulator, which is also temperature compensated. And so you can tell it to send really accurate, really fine-tuned, fine-grained voltages. So let me plug this back into the demo we're going to do in a second, and I'll show you a couple of nifty things about this. But before I do that, let me jump over to the page. Here's the product page for this. So this is it. It's the AD5693R breakout board. It says 16-bit DAC I2C interface. You can use that with STEMMA QT quick cable. And if you take a little scroll down, you will find a link to the Learn Guide. So this is a pretty new board, pretty new Learn Guide, and here it is. Thank you, Liz, for putting this together, as well as the library and some examples for this. So here's the product page. You can see a beautiful picture of it right here. Notice right there at the top you have a little optional, this doesn't come with a terminal block, but optional for one of the little terminal blocks that we sell, or you can just solder connections, wires right onto it. And you can use STEMMA QT from the little JST ports on the side, or you can solder in the header pins and put that down onto a board. This is a, let me grab my notes here because I want to give you a few little facts about it. So here we are. So you've got 16-bit precision. You can use up to 2 of these on one I2C bus. There's a little jumper. You can see it on the back there. If you solder that shut, you can set the second address. So you can talk to 2 of these on one I2C bus if you want. And like I said, you can use this with 3.3-volt logic boards and get up to a 3.3-volt output. Or you can use this on 5-volt boards, get up to a 5-volt output. You can use gain settings inside of it to jump from the 2.5-volt reference up to your input voltage level, up to the 5 volts at max. And we've got libraries for this. So if you take a little scroll down, head to the pinout page, you can see what each of those pins are used for. Let's see. Yeah, we'll talk about this for a second. Okay, so voltage in, that is a broken out pad that you can use if you're plugging into a breadboard or protoboard, or that's the voltage coming in over your I2C. So that'll be essentially your maximum voltage depending on the type of board you're using. VREF, that's the voltage reference pin. So you can, I haven't tried this, but I believe there are cases where this works better than others, where you can feed it a reference voltage, or you can pull that 2.5-volt reference off of there if you want to test it for some other reason or use it elsewhere in your design. And then we have the common ground pin. We have the I2C logic, serial clock, serial data. There is the DAC output, so those are those 2 terminal block positions that you see up at the top there, as well as 2 other broken out pins, and that gives you your voltage. And then there's the address jumper there. There's also a couple extra pins. There's the LDAC pin, which you can use, I believe, to set more permanent settings onto the chip, things that you might set in your setup, in your code. You can have it boot with those settings. It's also possible to give it a voltage level that you want it to always send as soon as it gets powered on, so it doesn't just drop to nothing until it gets voltage once the code starts. So you can give it a voltage setting that it'll always use. And then there's also a power LED built onto there. So as far as code and libraries go, if you click on this Circuit Python and Python link, this will show you a nice little fritzing diagram, how to set it up, what all the pin assignments are, either through the I2C STEMMA QT cable or through the I2C pins, as you see here with this example with a feather. And then also how to set it up on your Raspberry Pi or similar single board computer. And then talks about the drivers. So we have the library AD5693X, and that covers a few different similar chips, but that's the one we're going to use for this one, which is the 5693. And then it gives you some example code here, and we'll go over some examples in a second. This is a nice one which sets your I2C bus to a high speed, since this can use a higher frequency I2C bus, initializes the DAC, and then in this case creates a little sine wave, 100 sample sine wave, which it'll then loop so you can see essentially the full range from 0 to the maximum value. And there's a nice little image on a oscilloscope with the sine wave coming out of it. And then, of course, we have Arduino for it as well. So similar setup for how to plug it together and get your libraries ready to use with this Arduino sample code. So let me take some questions in the chat, actually. So the question from Tyeth, how would this function for synthesizing audio? So this is a great question. This is not, since we're running over I2C, we're not going to run really high frequency stuff. So we're not really going to get into audio rates unless you have really good hearing, because we can get into like the 20 hertz kind of range, pretty low frequency. But it is excellent for creating voltages that can be used to modulate things in synthesizers. So in fact, a demo I'll show you'll hear some synthesized sounds which are made with a proper audio rate oscillator, but we can use this DAC to send either pitch information, which is a volt per octave for pitch, or just modulate things, to essentially twiddle knobs for us with the DAC. So, oh, hey, Cryptnip. Cryptnip said they just got their first 16-bit DAC in the mail today. Woo! Way to go. P. Curry in a Hurry says 3 octaves of quantized 1 volt per octave should be possible then. Yes, and I'll demo that. We'll be able to do 3 octaves of pitch information with this. And you can get up to 5 octaves if you used a board that's at 5 volt logic like an Arduino. Okay, so how about some demos? Let's jump over here to demo land. Okay, so you can see here, in fact, let me give a full view of the board. So you can see here, I've got the DAC board, 16-bit DAC board. I have it plugged into a QT Py over stemma QT. And then output, I have the screw terminals going to a little stereo, or actually a mono jack, a little 3.5 millimeter mono jack. And that's heading out to 3 things. So we have a scope, little oscilloscope here. We have a multimeter here showing the voltage. And then I also have it plugged into a synthesizer. So I'm going to just set my offset on this oscilloscope to drag the center line down a bit so we can see it. So it's already doing stuff here. So that's the setup. Let me show you some things in code, and I'm also going to turn on a little audio. So I'm going to take a moment and just see if anyone can let me know how the audio levels are. I want to make sure that you can hear that sound as well as my voice still. And I don't want to yammer on too much until we figure out if that's working well. Let me switch my view over here to this. There we go. Let's see. Happy here, says Ty. Thank you so much. All right. So let's go forward. Okay, so what I'm going to do, I've got this plugged in and ready to go. So I'm going to resave my code. Okay, so now here's what we have. I am telling the DAC right now to send out 1 volt. So that means that I'm seeing 1 volt show up on my multimeter here. And I'm seeing essentially a steady line on the oscilloscope, and this is at the 1 volt level. And you're hearing that the 1 volt is being used by my little synthesizer off to the side to tell it what note to play. So that's our sort of baseline. Now you can see the way this is set in code is this DAC value. So if I set this DAC value to, let's say its maximum number, which this is 16-bit, so I can do 65535. And I'll go ahead and save that. Okay, so that's that 3.3 volt level. And in fact, we don't even need to go that high at 3.3 volt with gain times 2, which is more in the weeds than I want to get. But that is giving us the sort of top voltage that it can do. Let's lower that, because that's really annoying. I'm going to go to octave 0. So I had some things pre-saved here. So octave 0 is sending out 0 volts, which you can see here on my meter and on the scope. So if I go up to octave 1, this is sending this 16-bit DAC command of set the value to 13120, which is what I calibrated to be 1 volt. So pretty typically when you're taking a digital to analog converter, if you're trying to get really precise so that pitches match, then it might not be mathematically exactly what you expect. And in this case, we're dealing with, I think, 15.4 bits because of the 3.3 volt DAC, or rather input reference voltage that I'm using. So we're setting that 2.5 up to the gain 2, which brings us up to 3.3. So this is nice. We can go and send it individual values. And then we can loop through stuff, which is what you heard at first. So I'm going to go ahead and uncomment this. And what I'm going to do is tell it, go from 1 octave to 2 octave. And let's just increment 1 of the 16-bit values per loop. And I'm going to take this delay out of here. So it should sweep really continuously and smoothly. So listen to this. There you can see we get a really nice smooth. You can hear it better than you can see it on my multimeter just because it's a digital meter. Now I have it stepping down. So those steps you're hearing, by the way, that smooth thing, that's the DAC performing beautifully at giving really precise voltages. When I'm stepping down, I'm actually telling it to move in semitones. So again, through some math plus some real calibration, I came up with 1093 as a semitone step for this. So let's look at a different example here. And what I'm going to do is, instead of adjusting my, turn the volume down, instead of adjusting my pitch with this, I'm going to say, okay, we'll leave the pitch alone, but let's twiddle a knob. So here's what our starting point is. So I'm going to, okay, so I've unplugged the DAC output, so this is just my little synthesizer doing its thing. And if I turn a knob, let me go to a different, yeah, this is buzzier. You can hear there's a sort of wave shape change that's causing some harmonics. So instead of me turning that knob by hand now, what I'll do is let's just plug the same wave we had going out from up and back down. Now I'm going to grab a cooler sketch for this, which is sort of a low frequency oscillator designed for this type of output. And I'm going to paste this in here. Now watch my scope. So I'm doing a fast sine wave. Then I'm doing this kind of stepped wave. And then I'm doing a much faster sine wave. Actually, that one might be a triangle, I can't remember. So if I go to a different type of effect with it, you can see we're sending out some really cool stuff, and we have the precision with the 16 bits to really dial in what we want. If it's a sound, if it's a modulation, this can do it, and it's just plain fun to watch that on the scope there. So let's see. Oh, Cryptiv says, I have a fun synth you can use. Oh man, there are so many fun uses for this sort of thing. And just look at this. You can package up a nice little teeny thing here, especially if you put this together on a little board, maybe added a battery to it, and you can have yourself a fun little DAC that will give you really precise results, which is really terrific. Let's see. What else did I want to show you? Here's some lovely product pictures of it, by the way, so you can see a little more clearly some of the outputs there that we're using. And let's see, what else? Did I miss anything? Someone asked, by the way, Yanis Konstantinopoulos asked in YouTube, is there a Discord server? And they found it. So for anyone else who didn't, it's at adafruit.it/Discord, and you'll get an instant invite, and then look for the live broadcast chat channel. And welcome, Yanis. Thank you for stopping by. Let's see, any other questions in the chat? Let me know. Peak in a hurry, yeah. For some of that, I was doing a chromatic semitone sort of quantized, so I was sending it those increments, and then you heard when I was just sending it free values that weren't quantized to any musical values. Let's see. Anything else? Is it also meant to drive an LED, asks Sam J. Ohio. Oh, let me bring up the Discord chat, by the way. That's an excellent question. I don't know what the current output is on this. Let me see if that's an obvious thing to find on the product page. And if anyone knows, let me know. We might need to look at the data sheet for that as well. I'm not sure what kind of current this is capable of, so I'm not sure about driving LEDs. Oh, thank you. Tyth says 20 milliamps. So yeah, one LED. It's a lot of DAC for dimming an LED. So you may be better off with other strategies like our constant current drivers or even just PWM, because you're really not going to drive more than one LED from this. Right. So what else? Anything I missed? Let me know. Those were the code samples I wanted to show. And if you look, actually, let me go back to one other real simple example here. Let's jump to this view. Right here, and I'm gonna copy and save that onto there. So here is the basic setup of this. All you need to do is import the driver, or the library, Adafruit AD5693X, set up your I2C bus. You can see in this case we're going up to the high frequency. And then to create the DAC object, you simply say DAC equals Adafruit underscore AD569x.Adafruit AD569x on I2C. And then you can feed it a DAC value, so any number up to 65,535, it'll send out that voltage. This one right now, let's adjust the code here. I will set it to the max. This should give me 2.5 volts when that restarts. It is not. Why is it not? What did I do wrong? Is that really running? Yeah, it is. All right. Did something get disconnected? What have I done? Let me do one. Quick change here. There we go. So there's something going on. Liz actually is working on the library. I think I had a sort of unofficial version running on here. So it was setting the gain to 0, I think, if I didn't specify. So this DAC gain allows you to set either at false, it'll use the internal reference 2.5 volts. If you set it to true, it will attempt to essentially do a 2x gain. So if you have 5 volt logic and 5 volts coming in, it will go to the full 5 volts. On the 3 volt logic, it'll go up to 3.3 as the maximum. But you can see here at the reference, this is the 2.5, it's giving me 2.5 when I put that up the top. If I, let's say, have that, we should get 1.25. There you go, 1.25 volts. So it's very easy to set. Just give it a number, and out comes your voltage, and then you can really have fun giving it different input, different types of knobs and sliders, sequences, some randomization, anything you want. Let's see. P. in a hurry says, if I chain 2 of the DACs with 2 addresses, how do I get both of them? I haven't tried it, so that's a great question. I would think you're going to set the address equals for one of them, maybe call that DAC1, and then a second one address equals whatever that second address is. I believe that'll work, and I think there's an example of some of that code in the Learn guide. Also, DJ73 said a multiplexer would allow you to chain them. Yeah, that'd be another way to do it with the same address, and you could get more of them onto one microcontroller. All right, I think that's going to do it. So before I go, I'll remind you, head on over here. This is the page for our lovely little DAC here, and you can get it for $5.48. It's a really nice DAC, high quality 16-bit DAC that you can get for quite a bargain here today. Maximum of 10. So if you have big plans, then this is a great time to snag yourself a bunch of DACs and go to town with those. All right, that is going to do it then. Let me unplug this, pull that out of there, and that is my product pick of the week. This week it is the AD5693R 16-bit DAC Breakout. For Adafruit Industries, I'm John Park, and this has been JP's product pick of the week, and I'll see you next time. Bye-bye.